morning or good afternoon, wherever you guys are at. We heard that we have international students joining us today, so thank you for joining us from Nevada. I'm here at me and Josh at the Nevada Science Center, our labs. This is our paleontology lab where we work on fossils and research from the state of Nevada. I'm the education director here. My name is Becky Hall, and this is Dr. Josh Bondy.
Hi, my name is Josh. I'm Director of Research here at the Nevada Science Center, and it is our pleasure today to collaborate and bring to you an awesome resource from Northern Nevada, so the other half of the state, up at the University of Nevada, Reno campus from the W.M. Keck Earth Science and Mineral Engineering Museum, and Director and Curator Garret Barmoore.
I'm glad to talk to you guys today. My name is Garret Barmoore, and I am the curator here at the Keck Museum. And we are located in Reno, Nevada, which is about 8 hours north of Las Vegas, if you've heard of Las Vegas. And so Nevada is actually, I believe, the 7th largest state in the United States. And today, not only am I going to be talking about the museum and some of our objects, but I'm also going to talk about what it means to be a curator and how to work in a museum. And I imagine many of you have been to museums, and there's many different kinds of museums. And there's many different kinds of work in museums. You can pretty much do almost anything in the museum field. So how I became a curator here is I worked as an archaeologist for a little bit, and I was very interested in telling the stories of the objects that I found. And ultimately, museum work is storytelling in many ways. And so I wanted to continue telling those stories and exploring these fantastic objects. And so I went to grad school, received a master's degree in museology. Other programs call it museum studies. I really like the term museology because in the Greek, it means the study of inspiration, which I really think sums up museum work in many ways. And then as a curator here at the Keck Museum, my job, I do a little bit of everything here, but ultimately what a curator does is that they manage and maintain the collection. So they decide what comes into the collection, what leaves the collection, and set standards for the collection. And most museums have what's called a collecting policy, which means they'll only collect certain objects that fit in their mission. And so being a Nevada museum, our mission is to focus on and promote Nevada's paleontology, mining history, and mineralogy. And while our collection does span the globe, in recent years, we've really narrowed our focus to kind of the Nevada and the Great Basin. The Great Basin is a larger geologic system that Nevada is part of. And so, like I mentioned, our 3 collecting areas have to do with fossils, rocks and minerals, and we're really strong in ore samples, which are essentially rocks or mineral samples that have a precious metal or another mineral that you're mining inside of it. So when you're mining gold or silver, it will come out of the ground in a rock, and then you need to process it to remove the material. And Nevada is a very prolific mining state. We are currently about the 3rd or 4th largest producer of gold in the world. And there has been mining in Nevada going back to about 1850. And so the Keck Museum has a lot of these historic ore samples. We have collections and samples that were collected 3,000 feet underground in a mine that has been closed for 100 years. And, but beyond that, we also have a lot of history objects. And I'm going to show you one of my favorite mining artifacts that we have at the museum. And I am going to wear gloves. These are nitrile gloves. And you've probably seen many museum professionals wearing gloves, and that is to protect the objects themselves. Because there are oils in your fingers, in your hands, that can damage a lot of historic objects. You don't need to wear gloves a lot of time with non-organic objects like rocks, for example. And in the museum community, we use the term proteinaceous, which just means that the object is organic or is made of proteins. And those objects are really susceptible to oils in your finger. So this object is a miner's cap that would have been used around the turn of the century into the 20s or 30s. And as you can see, it is soft. They wouldn't have been wearing hard hats at this time. In fact, the modern hard hat for construction workers was actually invented and first used at the building of Hoover Dam, also here in Nevada, down in southern Nevada. And so this would have predated hard hats. Now this device here, might look funny, but familiar at the same time. This is what's called a carbide lamp. This would have been the light source for the miners. There would have been down up here, there would be calcium carbide, which itself is mined, and then water, and the water would drip onto the calcium carbide, which would release a gas that was flammable, and the gas would come out here. You'd have your little starter, and it would start, and there would be an open flame. So you would actually have an open flame right on your hat. Working in the mines. And these also, the carbide lamps could be removed and hung. And this was, miners really, really liked the carbide lamps. Before this, they would have had a candle on their cap. And so this gave them a lot more control. And in some carbide lamps, you could actually control the flames. It could be brighter or darker. And carbide lamps are still used to this day by some spelunkers or people that go into caves and go caving. And miners also liked the carbide lamp and the open flame because it was a really convenient way to light fuses or light other candles or things in the mine. And a lot of times when we're talking about mines, people think that cave-ins or caves, as a lot of times they were called, are the most dangerous part of working in a mine historically. But in reality, especially around the turn of the century in the 19th century, the most dangerous part of working in a mine was fire. And that was because of all the timbering and wood that was underground. And of course, when I'm talking about historic mining, I'm talking mostly here in Nevada. And so fire was a major concern, and there were some major historic fires here in Nevada in the 1860s predominantly. And not only was it extremely dangerous to the miners, but it could completely shut down a mine and make the mine unsafe to reopen. So we have a lot of mining artifacts in the museum. And what's cool, once again, about this cap is it was never used. So this was what it would look pretty much almost brand new, and this is about 100 years old. It's in pretty good shape. And that's one of the important parts about a museum, is to preserve objects for the public, for everybody. By having an object in a museum, that means it's accessible to everybody. And a lot of people ask me if I personally own the objects in the museum, and I don't. The people of the state of Nevada do, and I just protect the objects. It's what we refer to as stewardship in the museum community. Now, another major part of our collecting area is the paleontology of Nevada. And one of the cool things about Nevada is for much of its history, it was deep underwater. And in fact, our state fossil, the Shonosaurus popularis, which is a type of ichthyosaur, was a marine reptile. And there's a great spot in central Nevada called Berlin Ichthyosaur State Park, where you can actually see several individuals still in the rock, still in the matrix. But this object is from another marine animal that lived several million years before the ichthyosaur in an era called the late Permian. And this is one of my favorite objects because it took paleontologists several years in the 19th century to figure out what it is. And we still don't know a lot about this animal. So what you're looking at, and some people think it looks like a fern or a shell or possibly an ammonite, but in reality, this is the lower jaw of a prehistoric shark called a helicoprion. And so, or shark type animal, there's still some debate. But what's really cool is, as you know, modern sharks, I'll get that a little closer, their teeth never stop growing. And they have rows of teeth, and the new teeth just push out the old teeth. With this guy, it appears that his entire lower jaw would be forced down and around into this shape, which is called a tooth whorl, W-H-O-R-L. And so you're looking at the jaw in profile from the side. And what's really cool is these tiny little teeth in here were the individual's baby teeth. And you can see how the individual grew over time. So we have several of these fossils in the museum, and these are mostly found in California, Nevada, and Arizona. And another question I like to ask people is, why do we only have the lower jaw? And one of the main reasons for that is possibly because the rest of the individual, the rest of the animal was made out of cartilage, which of course is kind of a soft bone-like material that makes up your nose and your ears. And cartilage doesn't fossilize very well. So all we're pretty much left with is this tooth whorl, which in many cases can leave us with more questions than answers. And that is very common in paleontology. Sometimes you just don't know until you find that next specimen, that next fossil that answers your question. And sometimes it can take years, if not decades. But one of the largest parts of our collection is our rock and mineral collection. And some of my favorite objects are from this collection. This is one of my favorites. So this is iron pyrite, also known as fool's gold. You may have heard it called fool's gold. And once again, this is how it was formed. We didn't polish this. We didn't do anything to it. This is how it was formed naturally. And pyrite is very common in this area. And we don't find it like this a lot of times, but there's a great lake, one of the largest alpine lakes in the world, just about 45 minutes from the university, called Lake Tahoe. And actually in the sand, you see these little shiny flecks, and that is pyrite. And pyrite was called fool's gold in the 19th century because prospectors would find it and thought they struck it rich. But in reality, at that time, it was pretty much worthless. Even though now, what we're finding is pyrite can be an indicator of microscopic gold. So they didn't really have the resources or the knowledge at the time to realize that they might actually be onto something, might be an indicator. And we have some amazing pyrite samples in the museum that are perfect cubes from Spain. And pyrite is cool because it forms in these perfect cubes naturally. And if you're really interested in mineralogy and identifying minerals in the field, one of the best ways to do that is to really have a good understanding of crystal habits, which means how crystals form, because minerals will only form in certain ways. So if you find something and it's a specific shape, that really narrows down what the mineral can be. So this object kind of transcends our collecting area. This is petrified wood. So this is, of course, fossil of wood. And it's kind of hard to see on the camera, but it is a bright red color. And a lot of times there's some confusion about the color of fossils. And fossils are not the color of the original animal or the original plant. That color has been lost. The color of the fossil or of this petrified wood has to do with the minerals and the rocks that, that it is made of. And in this case, the red color tells me that there most likely is iron or iron of some sort present in this piece. Because if you've ever seen an object rust, and you see that kind of brownish red, that is the iron oxidizing. And red is indicative of iron. But many minerals oxidize. Copper, when it oxidizes, it kind of turns a green color. And so if you're out in the field and you see a hill with a bunch of green in it, there's probably copper there, or with a bunch of red, it's probably iron. And we've been talking about being out in the field and collecting. And I hope that most of you have a rock collection. It's really a lot of fun to collect. But when collecting, it really, from a museum perspective, it is really important to have a very strong idea of what you want. Because the Keck Museum here has been collecting for about 150 years. And we were founded in 1908. So our collection is actually older than our building. And because of that, we are running out of space to keep things. So it is really important for us to be very specific and focused on what we collect. And that's why we are focusing mostly on Nevada and those 3 collecting areas. If somebody were to say, bring in let's say they brought in a piece of a railroad tie that was the only surviving tie from a very important historic railroad. That might be in a museum. That should probably be preserved. But the Keck Museum, it's kind of outside of our mission. So we would probably not accept that. But we would work with the donor to help them find a location for that object. And museums are really important places to preserve objects for the public and to make those objects accessible. But museums don't always do the best job of feeling welcoming and feeling like you can come into the space. But it's important to remember that museums are for everyone. And most museums and most museum professionals want you to come in, want you to ask questions, and want you to engage with them. And if you're interested in working in museums, the best way that you can do that is to volunteer. And I've heard from some of the other students I've worked with that they're concerned they may be too young to volunteer at a museum, but it never hurts to ask. And I know several museum volunteers that are in 4th grade or 3rd grade, and just being in the space and answering questions or working. And that's the best way to really break into the museum field, is to start volunteering. Okay. Well, I'm hoping that maybe we can get a bit of a discussion going.
Absolutely. We have a number of questions from some of the students.
So we do have questions. Very good.
We have a lot, quite a few, from all over the world. Now, those of you who are joining us, we have students right here in Nevada tuning into this. We have students from Florida, California, Ohio, Spain, Italy, and France. And so again, if you guys have any questions at all for Garrett or our friends at the Nevada Science Center, just go ahead and message them in the chat. But we're going to go ahead and begin. I got quite a few questions from one of our students who, it sounds like she's interested in working in geology, but I'll unmute her. Christabella, you should be able to ask one of your questions, so feel free to ask Garrett. You should be able to unmute. If she can't, I will ask one of her questions. So she would like to know, since you don't have space in the building, a lot of space, if you guys are running out of space, what do you do with all of the artifacts if you're running out of room?
That's a very good question. So one of the reasons why we're running out of room, is storage of the artifacts that we already have. And so when somebody brings in an object, a lot of times we have to say no, because in the museum field, as a museum professional, it is actually unethical for me to accept an object if I can't care for it. And part of that care is having space for it. So we are working on trying to get more space and additional space. But a lot of times we have to say no to objects. And if we do that, and it is a very important object that should be preserved by a museum, we will work with the donor to try to find another place for that object, another museum. And there's over 100 museums in Nevada and alone. And so there are many places that they can end up. And our goal is to make sure that these objects end up in public hands or are publicly accessible, even if it is not necessarily at our museum. But yes, space is a problem that all museums deal with. Even the Smithsonian, the National Museum of the United States, are constantly building warehouses to store new objects. They're constantly on the verge of running out of space. And most museums only exhibit about 5% of their collection. And that number holds true for the Keck Museum.
It's very interesting. We have Sarah. Sarah, you should be able to unmute. You had a very interesting question. I was kind of wondering this myself.
I would like to ask you, where did you find your objects? Because I heard you said that you have donators, but do you have, for example, archaeologists that work for the museum and go and find stuff somewhere?
That's a very good question. So most of the majority of our collection has either been donated or collected by university faculty. And so donated objects can be donated by anybody. So some of these objects are donated by mines, mining companies, are donated by individuals, what we in Nevada like to call rock hounds, which are people who like to go out and collect rocks. They'll donate a lot of times, but then we also do accept thesis collections or collections that were put together by a graduate student working on their either master's or PhD thesis or dissertation. And also professors will donate objects that they have collected in the field. A couple of the objects that we have recently accepted have been samples of brand new minerals, which faculty here at the Mackey School have discovered. And part of having your mineral being accepted by the board that decides new minerals is it has to be housed in a museum. And so we provide that service for faculty. And in fact, one of the largest collections that we just accepted is a longtime supporter and donor of the university just passed away, and he left his collection to the university. He was a leading exploration geologist for Phelps Dodge, which was a mining company in the early 20th century. And so he left several ore samples and mineral samples and all the paperwork and the field notes that go with it. Now, we work very closely with you and our faculty, but we don't have really any geologists or paleontologists on staff here at the museum. We're actually a relatively small operation. In fact, I'm the only employee at the Keck Museum. But we work very closely. As being part of a university, we can work very closely with the rest of our faculty. So I hope that answers your question. And at any point, if you ask a question and I don't fully answer it, please follow up.
So I know, Matt, you still had your question. Did you still want to ask that?
Okay, yeah, fine, it's fine. Nice to meet you, Mr. Barmoore.
Nice to
I
meet
would
you.
like to know from you, what was the first object you exhibit at the museum?
Oh, that's a very good question. So my first exhibit at the museum was about extraterrestrial rocks. So we actually borrowed moon rocks from the Nevada State Museum. In fact, every state in the United States was given moon rocks in the 1970s by President Nixon. And so the Nevada State Museum actually has samples of rocks collected during the Apollo missions on the moon. And then the Keck Museum also has several meteorites in the collection. And so we had an exhibit on moon rocks and meteorites and tektites. Now you probably know what a moon rock and a meteorite is, but some of you may not know what a tektite is, and they're super cool. So tektites have been known by humanity for thousands of years. In fact, there was a scarab made out of tektites found in an Egyptian tomb. But what a tektite is, it kind of almost looks like obsidian. It's these little guys, kind of a mixture of obsidian and a tiny little meteorite. And for years, scientists had no idea how they were formed, no idea at all. But just about 20, 50 years ago, they figured out what they think it is that when a meteorite hits Earth, it throws material up into the atmosphere, and that material actually goes up into the atmosphere itself, and the friction of the atmosphere turns the silica into natural glass, and then it comes back down to Earth. And so it's pretty cool.
So one of the students wants to know, what's the rarest gem that you guys have there at the museum?
Very good question. So we, admittedly, we don't have a huge gem collection at the museum. We do have some corundum, which corundum is the mineral that both rubies and sapphires are. Rubies and sapphires are just a fancy name for red and blue corundum crystals. We do have some diamonds, but probably the rarest object, it's not a gem, it is a mineral, is wakabayashi, and named after Dr. Wakabayashi of Japan. And it is related to realgar and orpiment, which are also minerals, which I'll talk about those in just a second. But it is extremely rare, and it was only discovered about 30, 40 years ago, and so most museums don't have wakabayashi, or if they do, it's gone unidentified. So that's probably the rarest object that we have in the museum, or the rarest mineral at least. And realgar, orpiment, and also wakabayashi are light reactive. So if there's too much light on the object, or UV, it'll actually start to turn into arsenic, the poison. And so you have to be very careful displaying orpiment and realgar, because if you're not, there'll just be arsenic poison in your display case.
The arsenic poison sounds dangerous. So some of the students want to know, where do you guys keep the extraterrestrial, the rocks, like the moon rocks and stuff like that? Is that near where you're at, or is it like locked down?
So the moon rocks are on loan. We're on loan. They're no longer here at the museum. We borrowed them from the Nevada State Museum in Carson City, and I believe they still have some of them on display. Now our meteorites, we've loaned those out to the Fleischmann Planetarium, which is at the north end of campus here. We do have a couple other meteorites on display, but our really cool big meteorites are up at the planetarium, and we have both rocky and metallic meteorites.
So some of the students want to know, what is the process of geodes getting created? So again,
Yeah.
We have a bunch of different classes here. They're teaching different stuff, so clearly they're learning about geodes.
So I'd be more than happy to answer that question, but first I'd like to just a quick caveat. I should have said this earlier, but my background is not in geology or even the earth sciences. All of my degrees are in the humanities. My master's degree is in museology and museum studies, and it is a terminal degree. But I have learned a lot about geology, and so I'll do my best. Please ask your earth science questions. I'll do my best to answer, but if I don't know, I will tell you that I don't know. And maybe we can figure out some way that we can follow up.
Well, we had, oh, sorry, if you wanted to jump in the geodes, I don't want to put you on the spot like that.
No, I will answer the geodes
Sure.
question, because it's essentially just there's an air pocket. Many times these air pockets in geology are called vugs, which I love that word, V-U-G, vug. And then the conditions are just right for a certain type of mineral to form in that air pocket.
Okay, and we had one of the students, they wanted to know, when they get back to school and when things go back to normal, are you guys Abe, are you guys planning on like allowing like guests in, like how things were before? Or do you guys have plans for that? Because it sounds like there's a lot of interest from our kids in Northern Nevada that want to check it out.
Yeah, so the museum is currently closed. We have been closed since March 2020, but we are hoping to reopen this summer. And I'm having some high-level conversations about that. And keep checking in. Now, I will say the museum is available for research. So if you are working on a school project or something that has to do with earth science, there is a way for you to come into the museum and access our collection. And when I say research, I don't just mean, PhD level. Like if you're working on a project on quartz and you want to come and see our quartz crystals, I have no problem going through that process with you. And also, I am doing these virtual field trips as well. So be more than happy to meet one-on-one with classrooms or groups.
And we appreciate you doing these, by the way. I wanted to say thank you for that.
Oh, this is the best part of my job. I love doing this stuff.
So I completely spaced because I know we had some geology related questions. And Garrett mentioned he's more so on the museum side. We actually have geologists here on this call. And so I'm going to pass it over to the actual geologists who have PhDs and are actually professional geologists and paleontologists. Josh and Becky, if you guys could answer that, how are geodes created?
I think Garrett did a fantastic job. So yeah, there's a space in a rock that's already there. Ground fluids are always going through the subsurface. So if there's dissolved minerals, dissolved ions, we call them in that water. Oftentimes quartz is the most common building blocks in the planet. So we'll get different minerals that build into those spaces. And so when you find lots of geodes, oftentimes they're filled with quartz because that's what there's the most of.
So there's another question. I'm going to just unload a few geology questions while we're here, and then we'll go back to the museum ones because we have both coming at me. So that the kids want to know, what got you into geology? Like what sparked your interest how can they go out and search for rocks? Dr. Bondi and Becky?
So what got me into geology was I grew up on the family farm and I always enjoyed being into outdoors, and I was always into fossils, and rocks are part of that. So it's just a passion that I had as a kid that was fostered by my parents, and I just followed that passion into my professional career.
Yeah, I grew up in Wisconsin, so same thing, a lot of outdoor activities. I like the natural science and geology and paleontology. So that's kind of how I got interested in it too. And I wanted to add a little bit to what Garrett was saying about having fossils and minerals in his collection there, is that we're kind of like the in-between stage. So we're researchers here at the Nevada Science Center. So we go and we are researching and learning about new fossils that we discover. We bring them back to the lab here in downtown Henderson, Nevada, where we kind of clean them up, do our studies, and then we have an agreement with museums to return the fossils to a museum so they can show the public what Nevada has or what we discovered. So we're sharing our research too. So we're kind of like the in-between stage as researchers, and Garrett would be taking care of if we were in agreement with their museum with our from our material that we found for our research.
And what's wonderful, a side note, you just answered like 5 questions with your one answer. So thank you for that.
Yeah.
And if those of you who want to see more of Josh and Becky, we have some Nevada Reading Week guest speakers that are open to the public that are out there in the chat for all of you guys to sign up for. I'm going to, if it's okay with you guys, because we have a number of museum questions for Garrett.
Yeah, please go back to Garrett.
We are going back to Garrett. So Garrett, they want to know if they're interested in becoming, working in museums like you, what kind of advice would you have for them in high school? What things should they study, and should they major in something particular in college?
So yeah, that's a very good question. So like I said, volunteering in the museum is one of the most important things that you can do. Just getting that museum experience, seeing what it looks like. I mean, if you could even get some of the larger museums even have opportunities for high school students for jobs, especially at some science museums, interpretive work, that sort of thing. So that is the number one thing. It's just getting some of that experience. And now, as far as majoring, it really depends on what you would like to do in a museum. And that's where that, once again, that volunteer work comes in. So try to do several different jobs to try to really figure out what you would like to do. If you would like to be a researcher or a curator, more of the academic side of things, then you would want to focus more on content specialty. So if you want to be, you know, a curator of paleontology at a science museum, then studying paleontology or geology or a related field in undergrad or graduate school is kind of where your trajectory. But if you're more interested in interpretation, education, and being an educator in a museum, then focusing on education and also some content specialty too. The content specialty is not as important on the professional side of museum work. Because, like, for example, my specialty, my profession is running and operating a museum and caring for objects. And to give you an idea, my undergrad degree is in international affairs with minors in historic archaeology and European history. And with those degrees and with working and volunteering at museums, I was able to be accepted into a museum studies program at the grad level. Some undergrad programs do have museum studies minors, UNR does, or other programs. And there also are some trainings and certificates that you can do too. If you go to the Keck Museum website, you can see our main email. If you would like more information on kind of how to, the nuts and bolts of getting into the museum field, feel free to reach out. But like I said, it really is your actual degrees, while important, the big thing is having that museum experience and just volunteering in museums. And I encourage you to volunteer at many different kinds of museums as you can, and working in different departments. So you can really try to get that experience and that feel for the work, because it is a very unique field, and the skills that you need are very unique. I hope that answers your question.
No, it absolutely does. So we'll go with a couple more questions. So the students also wanted to know what originally sparked your interest in history. I mean, was it like Indiana Jones? What do you think?
Well, I mean, I admit that I loved Indiana Jones growing up, but nowadays I see myself more as Marcus Brody than Indiana Jones. But I've always loved history growing up. History has always been a passion of mine. And I grew up in museums. One thing that I had going for me is that one of my parents worked at a museum. So I grew up in the museum community. And I did the whole thing in college where I wasn't going to go into museums. And then I was pulled back in. And now I love museums, and this is what I do. I hear sometimes when people say that they don't like museums, my response to that is then the museum community has failed you, or you haven't found a really good, good museum. And the same thing can be said for history. If you find history really, really boring, it's probably because of how it's being taught. History is just stories, and there's some amazing, really unique, ridiculous things out there in history. And it's always fun, just jump on Wikipedia and go down a rabbit hole to see where you end up. And that's not just with history, that can be science, or it can be anything. So I've always been passionate about history and museums. And my first, one of my very first history passions I remember as a kid was the Titanic, learning about the Titanic.
Interesting.
Yeah.
And for those of you down in Las Vegas, and those of you who are not here in Las Vegas, we do have a Titanic museum at one of the casinos, which is a little weird. Yeah, I see some eyes went up. If you come to Las Vegas, I think it's at Mandalay Bay, one at Luxor, we have a Titanic museum. And, so it's fun. Yes, we do. So before we let you go, is there any advice you could give to these kids as they kind of go off into the world, whether they want to go into paleontology, whether they want to go into history or geology, even if it has nothing to do with that? As somebody who is very accomplished in his field, what kind of advice would you have for these kids as they figure out what they want to do with life?
What I would say is, it kind of sounds like a cliche, but do what you love and follow your interests. And if you're really passionate, interested about something, then cultivate it, grow it. I mean, it's like a plant or anything else. Feed that passion. And it may not end up being your job, and that's okay, but it's still okay to have that passion. Or it might end up being your job. But don't let anybody tell you that what you love is not important, or you as a certain type of person shouldn't like or be passionate about that thing. If it makes you happy, if it really excites you, that's all that matters.
Some great sound advice, and I'm going to hand it off to our friends at the Nevada Science Center. Thank you again, Garrett. We appreciate you so much, and we are looking forward to you guys opening so we could come and visit you guys up in the cold north of Northern Nevada. So I will replace the spotlight. Josh and Becky, you guys can take it away.
Do you want to continue with that question about what was it?
Oh, well, we have 2 geology questions still up.
Okay.
If you guys, the students want to know, how do they find these moon rocks and these Martian rocks? Like, what is the kind of process, and how are you guys able to identify that that's what they are?
Well, like Garrett was talking about earlier, some moon rocks came directly from NASA missions that went to the moon in the late 60s, early 70s and brought rocks back. Other than that, Martian rocks and meteorites and moon rocks have been collected by meteorite collectors and people who study the study of meteoritics. And the way they can tell if they're either moon rocks or Martian rocks is looking at the chemical fingerprint within those rocks, looking at the isotopes, different ratios of, say, oxygen 17 for those of you who are chemistry dorks like myself, can tell you roughly where in the solar system a certain rock came from. So that's how we know where those things came from.
So I have a question from a girl who's interested in geology. So this is directly, not for you, Josh, this is for Becky. So what kind of advice would you have for girls who want to go into geology? Is there, like, how can they get out there? Is there geology groups?
So there's definitely geology groups. It really depends on, what grade level you're at. I was a Girl Scout growing up, so I know that we were able to go and do adventuring as a Girl Scout, but I know there's other groups besides Girl Scouts, but that was an important part of me going to camps. But even at the college level, just being confident in yourself. There's definitely, now at universities, they're more inclusive, but sometimes it can be harder for girls sometimes to have a voice or get met with a little bit of discouragement. But I just say, just stay, if you're passionate about it and that's what you want to do, stay focused, and you can do it. And don't get, if you meet a roadblock or a setback, everyone does. So like Garrett was saying, like, follow your dreams, and being cliche about that, it's true. Like, be passionate about something. And if you run into a hard time or a roadblock or a setback, don't let that discourage you completely. Find someone else to, maybe a mentor or someone else that you can go to for advice, or just get up and try again, like that. I've had to do that more than once. And so I would just say, just don't get discouraged, male or female, you're going to hit roadblocks. And just be confident and be strong and just continue with your dream.
And can you, before we let you guys go, can you tell us a little bit about some of the stuff you guys are doing at the Nevada Science Center and some of the events that you guys have coming up?
Real quick, can I just
yeah, of course, Garrett.
Yeah, I just also would like to say, for on that same note, for those of you in Northern Nevada, the Mackey School, which is what we're part of, and it's also the department that has our geology department here at the university, is having a Girl Scout camp focused on geology and mining engineering this summer. So you can go to the Mackey School website to check that out. Plus, the Mackey School here has a group called the Lady Muckers, which is an all an all-women mining competition team. It's actually one of the first women competition mining teams that competed internationally. So I always think that's cool.
And that's mining is one of the major things that we're known for in Nevada to all of our international friends. We like digging in the state, in the Silver State. So before we let you guys go, I'm going to hand it over to Josh and Becky. Josh and Becky, can you guys tell me a little bit about the Nevada Science Center? I'm sharing the website out with everyone. What kind of events do we have coming up?
All right, so as the education director, I'll kind of talk about some of our outreach programs that we have going on, and then I'll let Josh wrap it up with some of our research going on real quick to give you an update on that. So we are going to continue with our virtual field trips for the spring. I'm getting them all up on our website, or if you want to add your email address onto our website to stay up to date on our information. We're going to be traveling across the state of Nevada with Ralph as our mediator, and we're going to be learning more about the science around Nevada and kind of letting everyone know worldwide what we have here that maybe you don't know about yet. So keep up to date. Our social media, we keep up to date, and on our website, sciencecenternevada.org. We'll get you that up-to-date information, and you can always email us too at education@nvscicenter.org. And then I'll give it away to Josh.
So some of the research project we have ongoing behind us, the kind of this weird looking rock behind us is actually a dinosaur bone. So we're digging up dinosaurs across 3 counties of the state right now. So this coming summer, hopefully we can get out and about with the world opening back up, getting a little bit back closer to normal. We're also digging up not ice age, excuse me, but older mammals from the age of mammals. So 20 to 10 million year old mammals from about 4 different counties in the state right now. So we're busy. That's keeping us running around. And so hopefully we can bring these stories to all of you.